What is the infinity shell, and why do I have shell in quotations? The energy level equation allows us to calculate how much energy is contained within the rings around a Bohr atom, which is a type of hydrogen. And these concentric rings which compose our atom are denoted by n and assigned a counting number based upon what order that ring is from the nucleus. The second ring, for example, is assigned n equals 2. Using this equation, if we plot energy amount against n value, we see that energy values are individual dots, are always negative and increase when n increases. But what if we take the limit of this equation as n goes to infinity? In other words, we plug in larger and larger and larger values for n. Well, the energy values we output are still negative, but they get closer and closer and closer to zero that, theoretically speaking, would get to an energy of 0. This is what we call the infinity shell. So if our electron occupies this infinity shell, it will also have 0 energy because electrons take on the energy of the shells they occupy. Now, this infinity shell is not an actual shell of the atom because infinity is not actually a real number that n can be, whereas n can be 400, so n equals 400 is an actual shell of the Bohr atom. Okay, so if this infinity shell doesn't exist, then what's the importance in talking about it? Well, this infinity shell is actually crucial to understand the connection or bond an electron has with an atom's nucleus, or lack thereof. We've established that our infinity shell has 0 energy, so an electron which occupies it will also have 0 energy. And if our electron has 0 energy, it's at the cusp of the atom, without getting close enough to form an actual bond with the nucleus. And also, it's not wandering away from the atom because, again, it has 0 energy. But something very interesting happens when our electron breaks the plane or circumference of the atom. It forms a bond with the nucleus. Specifically, the proton and electron form a stabilizing electrostatic attraction, which is also known as a chemical bond. And in creating this bond, our atom releases energy from the electron. So if our electron starts from a 0 energy, it will take on a negative energy. This is exactly why shell energies and correspondingly the electrons which occupy these shells have negative energies, because energy was released in forming a bond relative to this 0 energy starting point. If we zoom in on the energy of the first 4 shells, we see how this works more clearly. Relative to our infinity shell, where energy equals 0, we lose the most amount of energy to get the largest negative value for n equals 1. But for n equals 4, we lose the least amount of energy relative to 0, so this shell is only slightly negative in energy. Consequently, this is the strongest bond because it requires an addition of the most amount of energy to bring the electron back to the 0 energy state, as opposed to the n equals 4, the weakest of these 4 bonds, because the energy required to get it back up to 0 is the least of these 4. That's the difference between forming a bond where energy is released and breaking a bond where energy is required. Here's a more holistic diagram to summarize this phenomenon, and I highly recommend you check out this video on your screen, Why Are Electron Shell Energy Values Negative, because it further explains this concept in an easy to understand way.